This document links to the functions and equations topics and the circular functions and trigonometry topics of the IB Maths course. It's specifically looking at the volumes of cones, and it defines all the variables that we require on page 1.3. As we go through the document, it checks on prior knowledge, and it just sees if students know what facts they should be taking into the activity, and these are self-check quiz pages. This activity is quite a long activity. It could be spread over several lessons, or maybe over a whole week. It goes through lots and lots of things, and it's forcing students to be very aware of the sort of mathematics they need to be able to do when working through these questions. So we have lots of questions at the very beginning, just setting the scene, and then it goes on and asks students to look at how you work out the area of a cone from simply just knowing the length of the slanting side, and you can move these so it's next to the side of a cornetto. Let's just have a look at that. So if I just knew that the slanting side was 9.2 and the apex angle was 25 degrees, the volume should be 37.3. And the students should be able to verify where that number came from their work from the previous pages. It's not the only dynamic diagram. We have other ones here to do with something that's actually used in developing countries for generating fresh water, drinking water. Again, we can just make measurements of the apex angle and the slanting side, and again they can verify where those numbers come from. So there is an issue of what is the maximum volume that you can get within this sort of setup. And so on page 5.2 we have a picture of a cone, and we have complete control over what apex angle to change. So if we decrease the apex angle, we get a taller, thinner cone, and if we decrease it, we get a shorter, fatter cone. And on the right hand side we see that the volume changes in accordance. And the challenge is to find out what is the value of the apex angle that leads to a maximized volume. And it's in the region of around about 110 or thereabouts, but it's not exactly 110. And so this activity then goes on to get students to consider what is the best angle to have at the top. And it talks them through the facts that they need to know, the formulae for generating the different lengths for the radius, knowing the slant height and the apex angle. And it starts to get them to construct an expression for the volume of the cone based upon those, and then we can simply go down to drawing the graph of it. The graph's not here on show, that's for the students to enter and construct on their own. And we get to the conclusion that there is a maximum volume of a cone from an angle of 109.5. It's strange to us but not to chemists, and there's a little bit of exploration there for the students to do. And then there are a few pages at the end simply to do with a little bit of fun, following their pages of toil involving heavy algebra. So this activity covers everything from basic trigonometry on right angle triangles and Pythagoras, all the way through to designing a function which you can look to optimize. There's no need for them to be able to differentiate. It can be used purely by using all the graph analysis tools. That's it. That's all it does.